Hello everyone, you're welcome to this channel once again. Today we have this peculiar question bordering the jet-propelled aircraft and how to calculate its thrust. Now, let's read through the following question we have. Consider a jet-propelled aircraft with the following parameters. With the wing area S equals 53 meters squared, the wingspan 20 meter, the weight 111 kilonewton, the zero lift coefficient CDO which is 0.02, the horsepower efficiency factor E 0.85. The aircraft is traveling with a ground speed VG which equals 187 meters per second at an altitude of 10,000 meters with a density above the sea level rho which equals 0.41 kilogram per meter cube. Now, the aircraft is flying a headwind of speed VW, which is the speed of the headwind, which is 27 meters per second. Now, calculate the thrust TR required to maintain the straight level and unaccelerated flight. Now, let's pull out all the parameters given for this our jet-propelled aircraft. Our X is given, which is a wing area 53 meters squared. The wingspan B given 20 meter. Weight is given 111,000 Newton. Our CDO is given to be 0.02. Our Oxford factor is given 0.85. Our VG, which is the ground speed for the aircraft, is given, which is 187 meters per second. The altitude of flight is given 10,000 meters. The density is given 0.41 kilogram per meter cube. The headwind velocity is given to 27 meters per second. Now we are asked to calculate the thrust. First of all, by deducing the aspect ratio, our aspect ratio becomes P squared over S. That gives us 20 squared over 53. It becomes 7.55. That's the aspect ratio. Now we can deduce that the mainstream velocity of the aircraft becomes the VG plus what? The VW. That gives us 187 plus 27, which is 214 meters per second. So our V is 214 meters per second calculated. Now, don't let us forget that the aircraft is flying and is trying to maintain its stability on a straight level on accelerated flight. So therefore, the lift is going to equal to the weight. So sin is slough. The lift equals to weight, and the lift equals half rho S V square CL. And since the lift equals weight, therefore our coefficient of lift becomes what? 2W over rho S V squared. So it becomes 2. What's the weight? 111,000 over what's the density? 0.41 multiply the S 53 multiply our V 214 squared. Our coefficient of lift becomes 0.2201. From there, we can deduce that our CD, which is coefficient of drag, becomes CDO plus CL squared over pi EAR. That gives us our CDO 0.02 plus what's our CL 0.2, which is calculated 2231 squared over 3.14 times what's for factor 0.85 times our aspect ratio, which is 7.55. That gives us 0.0225. That's our coefficient of drag calculated. Now from this we can deduce that the thrust equals the drag during the straight level accelerated flight, just like the weight equals the lift. So therefore our TR, which is the thrust, which equals the drag on this particular flight, equals half of rho S CD, our mainstream velocity, equals to, so that gives us half multiply by 0.41 times S, which is the area, 53, times CD, which is calculated 0.0225, times our velocity, which is 214 squared, which gives us 1.18 kilonewton calculated. Thank you very much for staying tuned.